I think one, I would challenge the notion that you need opaque or black box models. We're trying to move away from that language, but that you need, your system has to include an opaque model. There's a great article from MIT that looked at when there are more transparent models being used, how they have become more explainable, more adoptable, and more understandable in that context. But I think guaranteeing safety is a false paradigm, perhaps, to aspire to, and this is just my opinion. We want to have trust, but my example of driving to the grocery store, there's no guarantee that I will make it to the grocery store in my car. My brother always says, when I say fly safe, he reminds me the most dangerous part is getting in the lift to get to the airport. And because there's risk involved. And I think that's the part where we have to better understand what's our tolerance of risk, when will we use it? And I think challenge the assumptions about how systems are being built today, because there's a reason huge uptake hasn't happened in all use cases. It means there's more to work on with the technology and how we're developing it, how we're designing it. It is certainly true that that a lot of what happens in AI is opaque. We don't understand why exactly it works. The engineer in me views that as a challenge of how do we get better? How do we grow our understanding? When is that true? When is that not true? To kind of explore it a little bit more. Matt, I don't know if you have anything to add there.
Well, Rachel, I think your focus on risk and understanding the risk framework in which, and the risk context in which these systems are being deployed and used is critically important. And like the engineering qualities, right, trade-offs between scalability and robustness, there are trade-offs that you can take on in the risk context as well. And so I think risk thinking, risk analysis is a big piece of understanding how these systems can be deployed. It's also important to note that so I wanted to mention that there is work in formal methods, right? So if presume some of the folks out there, because we're the Software Engineering Institute, are very familiar with software engineering ideas. I don't want to get into explaining really what formal methods is, but formal methods is a method for making guarantees about systems. There is ongoing research and recent breakthroughs on applying formal methods thinking, formal verification to deep learning systems, to neural networks, to make some guarantees about the boundaries of where those systems might go out of their operational domain. And so that's pretty promising research still in the science side of things. From an engineering perspective, and again, channeling our software engineering roots, in traditional software engineering, you have a lot of tools for introspecting, analyzing, unpacking the behavior of a software system. These are tools like static analyzers that actually go through the code and analyze it for failure modes, for bugs, for violations of secure coding principles, those sorts of things. We do a lot of work in those areas at the Software Engineering Institute. There's also dynamic analyzers, which are the sort of runtime analysis of systems, and then even reverse engineering tools. And I think there's a great need, and this is an area we've identified as critical to AI engineering, and some work from the explainable AI and interpretable AI communities on how do we build those same sorts of tools for these models. And like Rachel said, I think it's important maybe to get away from this idea of black box or even that language, but just there's a model there, and how do I understand what it's doing, and how do I analyze it? And how do I test it on its boundary conditions? And how do I find those failures or bug modes? And so there's again, interesting developments in this field. There's some tools out there already that you can find in open source or in the public domain for starting to get at the analysis and understanding of these types of models.
The other thing I would add is just that I think in this day and age, we have to continue planning for uncertainty. Certainly COVID-19 threw everybody a curveball and helping us, and forced us to look at the uncertainty, the unmodeled phenomena that exists in the world, and that we can't anticipate everything that's going to happen and build them into our models. I think it's hard, there's a tendency for us to want to plan for and control all possible scenarios, and stepping back to say, things are definitely going to emerge that we don't know what to deal with. There are definitely factors that will emerge that will compromise our systems, that will make them less robust. how do we start to plan for that? How do we build that resilience into the design so that we can tolerate these system shocks in a different way, that versus hoping and crossing our fingers that we've thought of everything that could potentially happen?